Hi everyone, thanks for joining us today to learn more about the platform development and capabilities of the RDCA-DAP. My name is Kara Lassiter, and I'm the project manager for RDCA-DAP development and implementation at Aridhia Informatics. I'm joined today by David Sibold, our CEO, and Rodrigo Barnes, our CTO, and we'll tell you about the platform foundation, current capabilities, and future plans. Today, I'll take you through an overview of the platform and share some context about its design and features and our role as platform providers. We'll also expand on some of the core use cases that drive current and future development. We've also prepared a demonstration to show you the end-to-end use of the platform, and it illustrates the research lifecycle to give you a bit of a taste of what the RDCA-DAP can do. Finally, we'll talk through where we go from here and what the future vision looks like. Firstly, what is a digital research environment, or DRE? The Aridhia DRE is a research environment designed for health data science and facilitates a platform for trusted data sharing networks. The platform comprises of FAIR data services and workspaces. FAIR is based on the FAIR data principles that were developed to address making data more findable, accessible, interoperable, and reusable. FAIR is designed to reduce the barriers to entry for discovering and understanding data, and enables dataset search, classification, and metadata browsing on the platform. Workspaces are scalable analytical environments that allow for research collaboration, data sharing, and analysis with built-in and bring-your-own tooling capabilities. The DRE is the foundation of the RDCA-DAP and provides a secure and audited cloud-hosted platform designed to meet the needs of researchers, data custodians, and other stakeholders such as regulatory and patient groups. Now, what does the DRE do for data controllers? Data controllers are essentially data custodians responsible for managing and safeguarding data. The DRE supports data controllers by providing a centralized and integrated platform for managing the visibility, services, and compliance for all RDCA datasets. FAIR takes center stage here by providing services such as data and metadata publishing, visibility controls, and built-in workflows for requesting and approving data usage. Workspaces also allow for research through a project approval pathway and offers a dedicated environment with permissions and access controls. The DRE is underpinned by comprehensive auditing and governance capabilities that support regulatory and legal requirements for the RDCA-DAP. The DRE also supports the full research lifecycle. Researchers can discover data in FAIR, select and gain access to that data, then transfer it to an approved workspace for subsequent analysis and visualization, where they can go on to share their findings with the rare disease community. Research workspaces also offer researchers and collaborators a secure and audited environment to work together with analytical tooling such as R, Python, and SQL. You can also bring your own data, code, and tools with the freedom to operate within your workspace. Virtual desktops and scalable compute resources are also available in the workspace to offer even greater flexibility. Now I'll turn it over to David to discuss our role and mission to support research initiatives like RDCA-DAP.
Cara, thanks, and good morning, afternoon, evening to everyone that's on the call. I'm glad to be with you all virtually. I'm David Sibold, I'm the co-founder and the CEO at Aridhia. And I just wanted to take a couple of minutes to add a little bit of additional detail about what we do at Aridhia, our kind of philosophy and our focus. And as Cara has covered, all our efforts center around the development, the deployment, and the support of customers to either build from and use the digital research platform for their clinical and biomedical research programs. So just as a little bit of background, we're a team of about 60 people based largely in Scotland with a multidisciplinary mix of skills in computing science, software engineering, data management, and data science, but all focused entirely on biomedical and health research. And we see our job as providing really two essential functions. First of all, sort of enabling the scientific and clinical community to discover data and to work collaboratively with others on that data to accelerate their research programs. And secondly, to enable wider dissemination and reuse of those data, those methods, those insights through our FAIR data services. So communities build on work that's already been done, and we remove the problem of data silos that tend to inhibit progress in sort of disease discovery and development. So the first of those is really about scientific productivity and time to results. We want our user community to focus on the science and to let us take care of the platform infrastructure. So spend time on science, not on tech. And the second is to make it easier to share metadata, data, methods, results with the extended community to optimize funding, but also crucially to optimize outcomes for patients. So within all of this, we operate within a tightly managed ISO 27001 security and governance model, ensuring that there's transparency and reporting on the use of data, particularly highly privileged patient data. And we act on the instruction of the data controller. So we have no access to or rights to any of the primary or secondary data. We're delighted to be part of RDCA-DAP, and we're delighted to be here today for the formal launch. We're looking forward to working with our friends at c-path and the wider RDCA-DAP community over the coming years. So congratulations on your launch, and I'd like to just hand over to Rodrigo to take us through a quick overview of some upcoming features as well as a demo of the platform. Rodrigo.
Thanks, David. So I'd like to tell you a little bit about what's taken us here. So in developing the data access platform with the Critical Path Institute, we've identified that there are, broadly speaking, 3 use cases and groups of users who we want to support. The first group of users really would like to explore and analyze the data. For example, what data is available in this community, and can I access it in a streamlined way? And this would apply, for example, to stakeholders from this group who may not be directly researchers or analysts, but want to get insight into the different disease groups, the populations, and the clinical characteristics of those groups. Whether you're a stakeholder or a patient advocate, we're looking to make that level of data access ready for you. If you're a clinical researcher, you're working in a team, maybe you're working across organizations, that's where our collaborative research use case comes in. And for this, you can bring in your team and use open or proprietary tooling, professional tools, for example, that you may be used to or that your community is developing can all be run in our workspace. And the accessible and secure cloud environment means that you've got a place for everybody to come and meet and work together. Finally, working with data contributors, and in particular the Critical Path Institute itself, we want to support the curation of rare disease data. So bringing together data from many contributors, harmonizing that, making that available in useful subsets for different user groups, enriching the data with additional semantics or other ways of making the data more consumable by end users. And at the same time, working with curators to make data more accessible, improve the way data is described, make it easier to link to from research publications through the DOI mechanism. We think this will have a good impact on the research community by reducing the time to insight, that productivity that David mentioned earlier, by having a place to discover, access, and work with data in a collaborative way. By offering a platform and a framework for working with data and sharing with data, we want to encourage that community and the redeposition of data. So if anyone creates derived data as part of their research, we can make it easy for them to bring it back into the community and make it available for others. This allows groups to build on existing work and extend their networks by finding new collaborators through our capability. So what we'd like to do now is give you a short demo of the platform. My colleague Andrew will be running a short demo, and hopefully that'll give you an insight of what's already in place. And I'll come back and talk to you about what our plans are in the next phase of development. Thank you.
The Rare Disease Cures Accelerator Data and Analytics Platform, or RDCA-DAP, is an FDA-funded initiative that provides a centralized infrastructure to support and accelerate rare disease characterization, with the goal of accelerating therapy development across rare diseases. The data and analytics platform includes FAIR Data Services and Workspaces. FAIR Data Services includes integrated rare disease data from clinical trials, observational studies, real-world data, patient registries, and other sources. In Workspaces, advanced analytics capabilities allow efficient and effective interrogation of data to generate insights, analyses, and solutions. FAIR has dataset search, classification, and metadata browsing capabilities. This includes data dictionaries, cataloging, and attached assets. From here, you can browse available RDCA datasets or search for the data you're interested in. We'll search for biomarker data that includes APOE status, a genetic biomarker important in Alzheimer's disease. While this is not an RDCA dataset, we'll be using this open data for demonstration purposes today. Datasets are displayed in FAIR with relevant descriptive catalog entry details, such as author, contact details, publisher, dataset rights, and creation dates. They also show keywords and attachments that provide extra context and enhance the metadata. Below you will find data dictionaries that describe the dataset and field-level metadata. From here, the user can request the dataset by filling in a data access request form with details of their proposed research and intentions. A link to the data use agreement for RDCA purposes will be available, and applicants must agree to it before submitting. The request would then be passed through an approval pipeline, where submission details would go through a screening and approval process specific to the dataset we requested. You can view all your requests in FAIR, filtered by their status as either pending, approved, or denied. In this case, our request has been approved and a reason given for the decision. Workspaces provide a secure environment for the collaborative analysis of healthcare research data. Teams can work within the secure boundary of their workspace to upload, access, and analyze project data, while taking advantage of an audited environment furnished with analytical tools, scalable compute resources, and virtual desktops. Inbound data is subject to an airlock function, where it is first screened and approved before being delivered. Here are our CSV files. If we select to analyze, it opens into a data frame with a series of medical statistics modules down the side. In this illustrative analysis, we focus on the relationship between amyloid beta and a number of other biomarkers. We'll start by selecting the A-beta column and producing a density plot. Now we can further explore the distributions by splitting this by APOE genetic status. We can save this output as a PNG file and give it a description. Next, we will build a linear regression model, looking at variables that might impact on whether a participant has an A-beta reading above or below 1000. This is to illustrate a fictional classification used in a clinical setting. Select your outcome variable, along with other predictor variables, before generating the final output. When using these modules, you can copy the underlying R code used to generate these visualizations to use in a script or model. We will now take that code and create a new script that generates the regression model and also creates a new dataset by extracting from the current one. Let's run this in the Workspace's inbuilt R console. Your model output is on the right, and we can see the newly created dataset in the Datasets folder. If we want to export our findings, we may do so by following RDCA data usage agreements and utilizing the appropriate data citations. We can use Airlock, a controlled and fully audited export feature that ensures only approved files and data leave the secure environment of the workspace. Once submitted, a Workspace administrator will review the request for approval, and we can contribute any findings, models, or results of our analysis to the rare disease community.
Looking ahead to where we would like to work with Critical Path Institute and NORD and the RDCA-DAP community, there are a number of things that we think will come into play and we would like to add to the RDCA-DAP platform. Of course, our primary goal will remain the same, accelerating progress in research disease by making it easier to access relevant data and work together on it. We can do a lot to reduce and remove the friction that's normal, unfortunately normal, in finding and accessing data. And some of the specific things we're working on right now that will come into play later, and we'd be very interested in collaborating with you as a community to get right for the rare disease community. For example, federated access to global rare disease repositories. We have an implementation of federated data sharing and federated computation that makes it easier to work with data remotely, even if you don't have direct access to the data. This allows us to do transnational research without worrying about data transfer. So as long as the data sharing can be done remotely, then as an analyst, as a researcher, you can work with that data. For a lot of use cases, you don't necessarily need access to the full real data set. You can work with synthetic data sets as a replacement. And this might be a way of getting data faster. So we've been working on a proof of concept, and that will be developing into production configurations over the coming months. This means that users can select an accelerated data sharing approval process if they will opt for synthetic data. If needed, they can always go back to the real data. In the FAIR tool, to help the discovery and analysis use cases that we mentioned earlier, particularly for non-clinical research groups and users, we are adding better tooling for cohort selection. You see, develop the cohort that represents the groups that you're interested in. Maybe you want to compare two groups within the population, and then very quickly see analysis and visualizations on those cohorts in a safe way. So thank you very much for your time this afternoon. Hopefully that gives you a good introduction to the RDCA-DAP and fits in with the rest of the day that you'll be hearing more about the program as a whole. We'd love to answer your questions and work with you in the coming months. Thanks.